10 years ago, the debate was SQL versus NoSQL, and I kind of skipped this debate. I was working on SQL databases. I've been working on SQL databases for 30 years, and I joined MongoDB recently. So here you will see my enthusiasm for MongoDB because it's new, but you will also see that I really love SQL and relational databases. So today the debate is more Postgres or MongoDB. I will explain why they are popular and what is really this debate today. And we will debunk some myths coming from the SQL, NoSQL times. I will also explain what is normalization, because the big difference is relational data model, document data model, and the goal is to understand which works, and also we will see that you can also do documents in tables in a relational database. So how to do it and what's the best, but more understanding what it is. So as I mentioned, today the debate is more Postgres, MongoDB. Why? Because they are popular. MongoDB had a rise of popularity some years ago, and now we see Postgres growing in popularity. When I say popularity, some people try to put some numbers like the Debunking engine, but I will not comment on that because it's an old bullshit conference, and those numbers doesn't really mean nothing. But the popularity, we can see it. Of course, there is still a lot of legacy databases. There are a lot of applications running on Oracle DB2, MySQL. But what I see for a few years is that for new use cases, developers want to go either on Postgres if they want SQL database, or they want to go to MongoDB if they want NoSQL database. That's really the two popular choices for new workloads, for new use cases. And so why those two databases are popular? There are a lot of Oracle databases, and the Oracle database has a lot of features, but the problem is the vendor locking and the aggressivity of sales and audit licenses. And I think that Postgres is very popular because it's really the opposite direction. It's not only open source, but there is no company behind the Postgres database itself. But there are a lot of companies with managed services. So you really have the freedom that you want when you want to escape from vendor locking. You will have the freedom with Postgres because you can go to managed service and you know that you can move without changing your application. It's not free, even if it's open source, because it has a cost to run it and understand it, but the freedom you have. In NoSQL, MongoDB is the most popular for document databases, but also because it's general purpose. There are a lot of NoSQL databases that are purpose-built for specific cases. MongoDB can do transactions on documents, but you can do also time series. You have different kinds of indexes for text search, vector search. So the reason for the popularity of those two. And so now let's see what I still hear about SQL and NoSQL, and I think there are a lot of wrong messages or messages that were right a few years ago, but not today. And for example, SQL is too rigid, or NoSQL is schemaless. If you look at it, I have a lot of text on the slides, but I will go fast and just explain the main point. In SQL databases, by default, of course, you have a schema, but you can do a lot of schemaless things. For example, you can store JSON in a SQL database. And the opposite is true also in a NoSQL database. By default, you have a very flexible schema, but you can enforce schema validation. So the rigidity of the schema or the flexibility of the schema is not a big discriminator. You can do both in both databases. Doesn't mean that they are optimized the best for it, but you can do both. Also, we heard a lot that SQL doesn't scale. NoSQL can scale, but is eventually consistent. And that, again, is not true. In SQL databases, you have lots of features that can release some ACID properties for bulk load, for example. So you can scale without all the consistency that is there by default. And the opposite is true in MongoDB, for example, or in Cassandra. You can tune the consistency and be fully ACID or not. So again, this is not a discriminator between two databases. They started very opposite, but finally you can do both on both databases. I've also heard a lot of things that I think are not true about normalization and denormalization. For example, the idea that normalization was there to save disk because it was expensive. I've been working a lot on normalized databases, and I know that it doesn't save disk to store in multiple tables and repeat foreign keys and adding indexes. The goal of normalization, and I will come back on that later, the goal of normalization to avoid duplication is for data integrity. It's not about storage itself. And the relational algebra was not something about the storage itself. It's more the data modeling. And data redundancy may be okay. Depends what you do with the data. If you have something that you update frequently, then it's problematic to update it in different places. But there is also lots of data that you insert and never update later. If we go a bit more on normalization and relational databases and relational model, I also hear some things like, my data is relational, then I need a SQL relational database. Or my data is objects in the application, and then I cannot store it in a relational database. Your data is not relational or not relational. The data model is a way to represent the data, but the data itself is probably objects. If you look at the business object, can be objects in your application language, can be tables. The physical storage is different. It's not the data itself that is relational or not. Basically, you can store any data in relational database, in document databases. The way you interact with it will be different, but data itself can be represented in different ways. I also heard some things like relational databases are relational because I have foreign keys between tables. And just to make it clear, relational doesn't mean relationship between the table. The relation in relational is the table itself. So it has nothing to do with foreign keys. And the relational model was there also to avoid pointers and strong links between the entities. And also you have different levels of normal forms. You have different levels of data modeling. And if you look at your relational database and compare with the relational theory, you will see that it's not exactly relational. For example, a relation cannot have duplicates. In a SQL table, you can. Being relational would mean that you always select distinct, and you don't do that. So that's the theory. But finally, does it really matter? I think it's interesting to look at the concept, at the theory, at the relational algebra, just to understand it. But you need to focus on what really matters, the problems it solves. Why the relational model was there to avoid repetition, repeating groups. The first reason is avoiding update anomalies. Do not have same data to update at multiple places because it can be inconsistent. Also, the goal is to understand the data. The relational model, the idea was also to have 2 dimensions table that you can put on a screen or print in or put in a file, understanding the data and evolving the data also. Being able to add a column to a table without changing the whole data model, or adding an attribute on a JSON document. That's the same. So it's good to know the theory about relational data model, but focus on the goal. There are reasons for denormalizations and there are reasons for normalization. So finally, we can store data in relational tables or in documents, and maybe documents in relational table in SQL databases or in NoSQL databases. And about SQL, also a reason why NoSQL was quite popular 10 years ago was lots of developers thought that SQL was too complex. And then they used an ORM like Hibernate to hide this complexity. But then you have other problems. ORMs are harmful if you listen to the DBA because it can generate crazy queries. So there is no good solution. And also the fact that SQL is too complex depends if you learn it or not. Today, juniors learn again SQL. 10 years ago, it was more difficult to find people who know SQL. So the most important is where you feel comfortable. And don't forget that SQL and the relational databases were made to simplify data access. The idea was really to provide a language like SQL for end users, not for programmers, for end users who do not have to know exactly how it is stored. So it was made to be simple, but finally, for the developer, it becomes complex, also because the programming languages have changed. If you program with an object-oriented language, then mapping that to relational tables may be more complex. Also, the complexity of SQL. I mean, it can be easy to write, but you have no idea because you have this abstraction from the physical layout. So you can run your query without knowing how it is stored, but then you may have performance problems, and then you have to read an execution plan. And it's not that difficult, but you have something else to learn. To explain how SQL can be complex or not, who understand well SQL here? And who understand well how null works in SQL? And by how it works is what is null, how it compares to a value, how it compares to an empty string, and that depends on the database, how it is indexed. If you look for a value is not null, can you use an index or not? Again, it depends on the database. If you have a unique constraint and 2 nulls, is it unique or is it duplicate? If you have a foreign key with multiple colons and 1 is null, how is the foreign key enforced? And also, if you think that null means unknown, does it still mean unknown when you see a lot of nulls after an outer join? So I think I have the answer for all that. And today I can say that no, SQL is not so complex and I fully understand how null works. But it took me 20 years to really be sure about the meaning of all those things. So yeah, it can be complex. It's something that you can learn, but when I started in databases, the people who were developing in SQL, they were learning only SQL, but today you have lots of languages to learn, and probably how null is handled by SQL is different from how null is handled in JavaScript or Java. So yeah, it can be complex, and there are some reasons why people might find it complex. Another reason is that the relational model is really nice when And SQL is really good language to process data within the database. But today, we also use SQL as an API between the application and the database. And there, you don't see the full advantage of the relational model. Because when you query, the input to the query are usually just color values. You don't input a data model that is relational. And the result of a query is a single table. It's not a relational model. It means that when you join multiple tables with a one-to-many, you have only one table as a result with lots of duplicates that you have to deduplicate, or you have to run multiple queries and then have other problems. So SQL is really nice when you stay within the database, and it was built for that, running in the database with stored procedures, and database vendors put everything to do that. But today, we also want more control on the data access in the application, and it can be more difficult. That's the reason why ORMs came. So if we compare the relational model, fully normalized, with a document model, more mapping the business objects, in a relational model, we put, I don't know if I can see the pointer. No? Okay. Yeah. So we put things, entities in different tables, which can be complex to query because you have to put everything together. But the advantage is that if it evolves, for example, if you want to build a table instead of a chair, then you have all the components. So it has advantages and disadvantages. With a document model, you directly interact and store the business object, which makes it easy initially to interact with the database. But then if it evolves, you need to build a different document. So advantages and disadvantages, and the big difference is how you interact with the database from the application. The relational schema was really made for a central database where you model the data before having all use cases. So if you put everything at its own place, maybe the queries are more complex and you have to join, but you can have more use cases on it. Where with the document model, the idea is that you do data modeling when you already know all the access patterns for an application, for a service, for a domain. So that's another example. If you have an order entry application where you have orders with lines and products in a normalized relational database, you will put all order headers together in one table, the lines in another, and then we'll have a foreign key to the products that are stored elsewhere. And then again, if you query, then you have to join everything. But at least if you have a new use case, for example, just look at the products, you can look directly at the products. In a document database, you will store the order all together with all information. And then you can place them physically differently, so it's easier to shard, for example, if you want to shard in different regions. Makes it easy, you just access to one order for this access, but if you have a new use case, then you have to think about where do I find the products? I may need to look at different orders. So again, depends how you build your application and how you interact with the database. For me, the main difference when choosing a relational database or a document database is really how your team is building the application. When I started in IT, we had one central database and many applications on it. Today, you have more services built for a specific domain where you know the access pattern, and if you have a completely different access pattern for a different domain, you want another database, and maybe you will stream data between them. The idea of the central database was not having to move data elsewhere. So it really depends how we work with the database. In a domain-driven design, you have a domain where you know the access pattern, and then you can take the advantage of a document model where documents are models exactly for the business object that you have in the domain. Just to take an example, so that's an example of a document model with orders and lines and products, and for example, you can store for one customer, you can store the recent orders. You don't need all the history of orders. You can also store the shopping cart there. So when a customer connects, can see the last order, can put products in the shopping cart. But another use case, for example, those who will analyze the sales of a product, they cannot really use this kind of model. They will use another one centered on the product, and maybe not with all information about customer, just some types. So you will have different databases for that. Where if you normalize, you can really build a model for all those applications, because you have a table of products, you have a table of customers, a table of orders, a table of order lines. But this is nice from a logical point of view, but it's not easy to work with it. For example, from the structure, the shopping cart can be stored in the order. It's just an order without having an order date yet. So you can model the shopping cart in the same table as order. But if you do that physically, you will fragment your table, because people put products in the shopping cart and remove it, and then you have a lot of fragmentation. So in practice, you will store it in the different table, even if logically could be the same relation. Another thing also, you probably denormalize some things, not even for performance reasons. For example, I have the price here. I have the catalog of the products with a price. And when you have an order, I have just a foreign key to the product. But what happens if the price of the product changes? The order was made with a specific price, so probably you will have also the price in the order. And for performance reason, probably you will store the total amount in the order, the sum of the prices quantity of the order line. So finally, in a relational database, you also denormalize a lot. And yeah, just saying that denormalization is sometimes required by the business. As the business, what they want when they change the name of a product. Do you want to change the name? In a normalized database, you change the name of a product, and that's really nice, because then all orders will show the new name. That's the goal of normalization, updating one place only. But is it what you want? Your customer did an order, you have sent an email with a product name, they have printed it on paper somewhere with a product name. Do you want that it changes? That if they go to the web interface and look at the order, they see a different name than what was printed because the name has changed. There is a business reason to denormalize maybe. So we can store documents in a SQL database with JSON. So JSON is not the first format for documents, but it's very handy format because it is parsable by programs and readable by humans. And you can store JSON in SQL databases. And again, the idea is not new. Even if those features with storing JSON as a data type are quite new, I've always seen objects in databases. If you look at the Postgres original concept, so 86, the idea of Postgres was to be able to store custom objects in the database. And if you look at the data types in Oracle 8, I think, so that's 25 years ago, nested table was there. Same idea as storing a document, the order lines within the order. So that's not completely new. And sorry, I just wanted to mention that Maybe I have that on another slide, but what is kind of new is that databases have optimized the storage of JSON in a binary format. But if you look at what you can do with it, you need also to look at how you index it. So you can use Postgres as a document database with one table and an ID and JSON on it. And in theory, that works. But if you look at the features that you have, you cannot have the same type of indexes if you store everything in a JSON versus in multiple normalized tables. You don't have query planner statistics, so you don't have the same performance. You have many differences. It's not because you can store JSON in Postgres that you have to store everything as a JSON. And basically, you have three choices. If you want to have some documents, some more flexibility in the schema, you can use a document database. You can split that and normalize everything in a SQL database, or you can also store JSON in a SQL database. Big difference is how it is indexed. The document database was built to index documents. Even if you have arrays in the JSON, you have the regular indexes that can handle the multi-keys when it goes through an array. In Postgres, you have different indexes. If you have a JSON with arrays, like the order lines, you must use a different kind of index, an inverted index, GIN, and you don't have the same properties. It's good for equality predicate. It's not really good for range predicate or to optimize a sort. So the type of indexing is very different. If you normalize everything, then you have very good indexes because SQL databases were made to index tables, but you have a single index per table. And then you may have a problem if you have filters on multiple tables. For example, I have a predicate on the order header and a predicate on the order lines. And then I can use only one index and then join and then filter. There is no multi-table index in relational databases. And we have the equivalent of multi-table indexes when you have a multi-key index with documents. So indexing is the big difference. I hear a lot, yeah, you have JSON in Postgres, you can do documents in Postgres. Look at how you update it, how you query it, and you will see that it can be different. So when choosing which database, the big difference is really the data model. Are you building a central database where you will have more application on it? Then probably a relational database is the best fit for that. So take Postgres. If you know your access patterns and you want a general purpose database that is easier for the application development because it follows the same objects, then a document database can be quite good. Also, the difference is how you interact with it. In SQL, because you have multiple tables, you have multiple statements. A query can join multiple tables, but you have one insert per table. So when I insert an order, I have multiple inserts, one in orders, one in order lines. That builds a transaction, and then depending how you use it, it can be multiple round trips with the database. That is not ideal. You can put everything in a stored procedure, and then you have only one call from the application, so that's quite good for the performance. But maybe you don't want to deploy your code in stored procedures in the database. So think how you want to interact with the database itself. With a document database, it's easier because the document maps to the business transaction. you have less problem. For example, we have seen at the first session for the database track how it can be complex for a database to know in advance all the intents of the transaction, to know how to optimize the concurrent access. If you have only one document that does everything that business transactions want to do, it's easier to manage the concurrent access on it. And also when you query, the big problem when you query multiple tables with a one-to-many, like the orders and order lines, you can run one query that does the join, and then you have to deduplicate the information from the one side. If you do a sum, you have the risk of summing the same data. Or you can run multiple queries, but then you have multiple round trips, and that's not easy. If you use an ORM to interact with the database, you know that you have different fetching strategy to choose, so it's not so simple. Where with a document, it is easier if you know your access pattern, because you directly access to a document. I have a lot of questions about which database is faster, and I don't think it's really the right question to choose a database. First, faster. Is it faster in the execution? Because the most important, in my opinion, is also is it faster to build the application, to have evolution on the application? Because the execution itself can be 2 times faster, 3 times faster. You can compensate with hardware, and it's not all slow or all fast. There are some use cases that can be faster in one database, some that are faster in another one. So that's not the big difference. Also, I do not recommend to look at benchmark to choose which one is faster, because benchmarks, either you have the same number or you have big difference like 10 or 100 times faster, and then that's just a vendor benchmark that's tuned for his database and not for the other one. Big difference is how you interact with the database. Is it easy? Because if it's difficult to do the data modeling, to design the application, if it's difficult, then probably you will not optimize it, and then it will be slow. Not because the database is slow, but just because it's too complex for your team, the skills in your team, to use it efficiently. And all databases can scale if you use them correctly. And all databases are really bad if you don't use them correctly. As I mentioned, if you use Postgres just as a document database with a UID and a JSON, then you will probably have some problems, because you don't have all the indexing possibilities that you can have if you split to multiple tables. In the same way, if you use a document database and you want to normalize that to many collections, even if MongoDB can join with lookup, it's not as optimal as joins in a relational database. So use it correctly. The most important is to understand how the database works, and choose the one where you are comfortable with and use it correctly. Also, using an ORM Hibernate on top of it, do you use it just to make life easier, or do you use it because you don't want to know what happens in the database? Because if you don't want to know what happens in the database, when you have a performance problem, you will not know how to troubleshoot that. I already mentioned about benchmarks. Another problem with benchmarks usually run something that is very different from your application. There are still a lot of database vendors running TPCC. What TPCC does is what people were doing 40 years ago in front of a single terminal, entering orders and thinking about it. This is not how modern databases work today. For me, the only advantage of benchmark is that if you run a standard benchmark on a database, it helps you to understand how it works. And if you find that one database is slower than another, rather than thinking that it's just that one database is bad and one is good, just look at why is it slower. Maybe you have a different execution plan because you have different kind of indexes or different ways to gather statistics. Also, it can be good to understand the storage internals in the database. For example, if you have documents, if you do document modeling because you map to business objects, probably the documents are large. If you store JSON B in Postgres, it's still stored in 8K pages, so it will have to be compressed and split. Can work well with small documents. For example, in Postgres, it's perfectly okay to have a relational table and just additional flexible schema in one JSON, but small. If you have big documents, then you will have problem, especially when you update them. And also the storage can be different in the different flavors. Postgres has a lot of forks. If you run a managed service, you are not running the full Postgres from the Postgres community code. Each managed service changes a bit or a lot in the storage, for example. One thing that is also very different, but derived from the fact that SQL databases have a central catalog that describes the database, where document databases still have a schema, but a schema that is more in the application. Having a central dictionary, central catalog in Postgres or SQL database means that when the database is upgraded, usually you have downtime, because there is this central point there where something must change without the application modifying it. So if you don't want downtime, it's probably easier with a document database, but keep in mind that you will need more code. You will have a flexible schema, but the code, the application must handle that. You don't have this logical independence that you have with a central catalog. But downtime is a problem in SQL databases in general. So basically, what is the best database? The best database is the one where your team is comfortable. You can take the best database. If you don't use it correctly, it will be the worst database. And you can take a database that may be not the best fit for your workload, but if you know how to use it, tune it, then it will be the best database for you. I have here just a quote from Vladimir Alshia, well known in Java and Hibernate, just saying the same thing. Schemaless doesn't mean that you don't have to do data modeling. You always have to do data modeling. Can be done in declaration in SQL in the database, or can be done in the application, but you cannot skip that. At some point, if you don't do any data modeling, you will not have consistent data. Another way to put it, it's quite good to know the path of least resistance, because when we are under pressure to release new features of an application, we usually take the shortcuts. And in a normalized database, usually the path of least resistance is not thinking about the access pattern, because you don't have to. You can do your schema without knowing all use cases. But then if you go too fast, you will not create the right indexes, because the logical data model can fit all use cases, but you need the right indexes for the access pattern. And then you go to production and you have to look at the queries, understand the execution plan, create the indexes, and that can be difficult later. If you choose a document database, the path of least resistance is what we have seen in the previous slide, thinking that you don't need to do any design, you don't need to think about the schema. But it's easy to go there because you can start quickly without a schema, but at some point you need to be sure that what you store in the database has a structure that can be used later. So that's basically all the idea I've put about that. I didn't answer which database is the best or which you must use, but I think you have some ideas about the difference between the databases, between the different data models, and also about the myths or the wrong ideas, in my opinion, like trying to find which one is the fastest and running some silly benchmark just to say, oh yeah, MongoDB is faster, Postgres is faster. You can make every database faster for a specific workload. Doesn't mean that it's not a good idea to run those benchmarks if you want to understand how it works. So run the benchmark, but do not just look at the response time. Look at the execution plans. Look at where is the pressure. Do you have pressure on memory? Do you have pressure on disk? That maybe give more idea about what you can tune in the database that you choose.